Okay, so we're going to talk about the concepts behind the basic differentiation rules, or how to find derivatives. The first one that we'll talk about is called the constant rule. It's very important when you're talking about derivatives, is it's all about the rate of change of a function, how a function is changing as you move from lower x values to higher x values. That is what this is all about. So it's about the slope in particular moments. So the constant rule says that the derivative of any value of any number c, so it's a real number, is always going to be 0. So don't make this more complicated than it really needs to be. If we said the derivative of, let's say, the number 2, well, that is 0. Well, think about this. If we graphed y equals 2, it would look like this. Right? Oops, that's a little bad. That's what it looks like. Look at the slope. What's the slope? It's 0. It never changes. The number 2 does not change as x changes because it has nothing to do with x. Okay, there's no x here. It doesn't change the value ever. Y is always 2 no matter what x is. So its derivative is 0. Any constant is the same because a constant never changes, so its derivative will have 0 value because it doesn't change. It's never anything. Okay? Then we come to this next idea, which is the power rule. Now, the power rule is very interesting in how it works. Is your derivative is going to have a power of 1 degree lower than the next, but it's interesting what you do with that exponent. The derivative of a function that is x to the n power. So a base of x is very important, and a power of n is going to be, we multiply everything in front by n. So we take that exponent and multiply down. We then keep the same base, but we then lower our exponent by 1. So where we had n before, we now have n minus 1. So a quick example of that would be the derivative of x squared. When we bring the 2 down, remember there's still an invisible 1 out there, but anything multiplied by 1 is just going to be 1. So you're going to end up with 2 times x to the 2 minus 1, which just ends up being 2x. So the derivative of x squared is just 2x. And if I did another example here, just real quick, x cubed, you're going to bring the 3 down. We have x. Original exponent was 3, and you take 1 away from it. Well, you end up with 3x squared. So you see kind of how these numbers kind of float together. Well, if we were to graph y equals x squared, so let's see. Okay, so we've got y equals x squared there. At any point on the graph, 2x will describe what our slope is. So if we go and say, okay, well, what's the slope at -1? So -1 would be this section right here. So we look at -1. Oops. Right, this line. Well, the slope of this line that I just drew is roughly about -2. It seems to make about sense. I mean, it's about right. Well, because if I plugged -1 in here, I would get -2. So what about if I wanted the slope as x equals 0? So if I plug 0 in, 2 times 0 would be 0. Well, look, the slope at this point is 0, because it's a flat line. And likewise, I can go around and keep doing this as much as I want. But the idea is that because we have some sort of power here, our slope is now changing very differently as we move down the axis. So we have to have a function describe how our slope changes. We have a few other things. The constant multiple rule. It's a pretty simple rule. It basically says that if we have some number, so like some number c, and we're multiplying it by a function, then your derivative is just going to be c times the derivative of that function. Okay? So you don't have to make things extremely complicated here. Any number that you have is going to work out. So it's like, the derivative, for example, the derivative of x squared, we said from the previous slide was 2x. Well, the derivative of 100x squared, this is just going to be 100 times 2x, which is 200x squared. And you can think of this in a few different ways. You can think of the 100 as being completely separate, or you can think of the 100 as just kind of riding along the front, where we're doing 2 times the 100 because it's a coefficient, and then taking 1 away from the exponent. So this is a good rule to know. Any coefficient is basically going to ride its way down. It's going to be a factor as long as we continue to take derivatives. See, after that, we've got the sum and difference rules. So sum/difference rules. This one's also pretty simple. It says that if we were to take the derivative of f of x, and we would add or subtract some function g of x, the answer here would be the derivative of our first function, plus or minus, depending on what we did, derivative of our second. So you don't have to consider everything together. We can consider them separately. So quick example here. If I did, this was x squared plus x cubed. So we've done this 2 slides ago. So the derivative of x squared is 2x, and the derivative of x cubed is 3x squared. So this example, it's just going to be, what's the derivative of x squared? Well, that's just 2x. And then, because this is a plus sign here, I add. And then the derivative of x cubed is going to be 3x squared. And that is it. You are finished. Okay, so adding and subtracting we can think of as separate parts. The last one that we're going to talk about today is the derivatives of sine and cosine. So derivatives of sine and cosine. So these are just definitions that you're going to have to know. The derivative of sine of x, this is always going to be the cosine of x. And the derivative of cosine of x is negative sine of x. It's very important to make sure that we consider this negative, and we'll talk more about these and some other trig functions in the future, but these are the basis of everything that we need to know right now.